Everyone, welcome to my YouTube channel. So here today we are going to be looking at reference angles. So what is a reference angle? So the reference angle is the smallest acute angle, that is an angle less than 90 degrees between the terminal side. The terminal side is where the angle ends, like for example from here up to here. So this is the terminal side. Between the terminal side and the x-axis. So this angle between the terminal side and the x-axis is what we call a reference angle. So it could be anywhere as long as it's between the terminal side and the x-axis. So now with that said, we are going to have something like this. Let's say we are told to evaluate a value such as the cos of 200, and let's say we have to evaluate the cos of theta for theta is equal to 225 degrees. We cannot just say cos of 225 and find the value. If we have the calculator, we can easily do that. So here we use the reference angle. So we are going to have something like this, knowing that we are going to move. So this is 90, 180. From 180 to find 225, we are going to move a bit like this. So this gives us, if you subtract already, if here and to here is 180, we are going to say 225 minus 180 like that. This gives us 5 minus 0 is 5. 12 minus 8, which is 4. So we are going to have 45 already. So that means to say this angle between the positive x-axis, okay, let me do this. This angle between the positive x-axis, or rather the angle between the x-axis, is the reference angle. In this case, it's 45 degrees. So to easily find 225, we are going to say the cos of 225, we are going to use the value. Now remember, this is the third quad and cos is negative, so we are going to say negative cos of 45 degrees. Why negative? Because cos is negative in the third. Remember what we said in the previous video, this is all students, which is all of them are positive in the first quad. In the second quad, it is only sine that is positive. In the third quad, it is only tan. In the fourth quad, it is cos. So whatever angle is negative, that means we attach a negative, then use the reference angle. This makes our math easier. So we are going to have the negative of, remember the 45 is associated with, if we have the 45 here, if we have the 45 here, we have 1, then we are going to have the root of 2. So knowing that cos is equal to opposite over hypotenuse, so we are going to have 1 over the root of 2. Remember, the cos of theta is equal to opposite over hypotenuse. Sorry, not opposite, but adjacent over hypotenuse. In this case, the adjacent to 45 degrees is equivalent to 1. So depending on the 45 you take, but it's still 1 over the root of 2. So the cos of 225 is equal to negative 1 over the root of 2. Now they like giving the answer in conjugate form, so we are going to remove this square root by multiplying the root of 2 and the root of 2 like that. So root of 2 times negative 1, it will be the root of 2, negative root of 2 over root 2 times root 2. What is inside multiplies each other, so 2 by 2 is 4. So we are going to have the root of 4. So this gives us negative root of 2 over the root of 4, which is a 2 like that. So this is what we say as our cos of 225 degrees. So the cos of 225 degrees is equal to negative root of 2 over the 2. Let's say we are required to evaluate the value of the sine of theta, cos of theta, tan of theta, cot of theta, cosec of theta, we are also required to, let's say the value of the sec of theta like that. So let's say the angle is equal to 510 degrees. So knowing this and our knowledge of coterminal angles, remember coterminal angles differ by a complete rotation. If you don't know what coterminal angles are, kindly watch the previous video on coterminal angles. So under coterminal angles, if it is big, it's either you add 360 or subtract to 360. In this case, the angle you are going to use is, this is 510, you can subtract. So the coterminal angle to 510 degrees is, we are going to have 510 degrees minus 360. So you do it by subtracting 360, which is going to give us 150. So coterminal angles are angles that begin at the same point and ends at the same point. So this is the simple angle we can use. So that means to say, wherever I have my sine of 510 degrees, instead of using this big angle, I can use the sine of 150 degrees, because coterminal angles will always end at the same position. Like for example, if you look at our 510, it will move from here to here. That's already a 360. 360 plus 90, that will be equal to 450. 450, then we are going to have something like this. So to reach 510, we are going to have something like, if you look at the situation, we will have to move 150 in such a way that the 360 that we have, 360 plus the 150 degrees, it will be equal to 0, 1 remainder 1, 4, 5. So 510 degrees. So this is our 510 degrees. In any case, if you just move from here up to here, it is still 150. So that is what we mean by coterminal angles. So in this case, the sine of 150 degrees will be equal to, now the reference angle is the smallest angle between the x-axis, not just the positive x-axis, but it is the angle between the x-axis and the terminal side. So in this case, what we are going to have is this, the angle between the x-axis and the terminal side. So this gives us the 30 degrees, because from here up to here it is 150. 180 minus 150 is 30 degrees. So that is what we are going to do. Now sine is positive in the second quad, so we are going to say that this is also equal to sine of 30 degrees. So using that knowledge, we can be able to find the value. So the sine of 30 using the special triangle, remember, as long as you are dealing with 30, this side is the root of 3. This one will be your 1, this one will be your 2. Just look, 30, they have one thing in common, which is a 3. That can help you remember. So we have the sine of 30 will be equal to, remembering that the sine of theta is equal to opposite over hypotenuse. The opposite to 30 is a 1 over the hypotenuse, which is a 2. So the sine of this value will be equal to 1 over 2. So that means to say, we can say that the sine of 510 degrees is equal to the sine of 30 degrees, which is equal to, we have our 1 over the 2. But if you're dealing with the cos of 510 degrees, which is equal to negative cos of 30 degrees. Why negative? Because we know that where the angle is ending at this point, where it's ending, it is in the second quadrant. And in this quadrant, cos is negative. Cos and tan are negative. So we are going to say negative outside cos of 30. So this gives us, what is our cos of 30? So if you remember the triangle, we are going to have something like this, 60, we are going to have 30, we have the root of 3, we have 1, then we have our 2 like that. So the cos of 30 will be equal to cos is equal to adjacent. In this case, we have a negative outside, the root of 3 over our 30 degrees is a 2. So we are going to have our 2 like that. So we have a negative. Likewise, let's say if we have the tan of 510, it is also equal to negative. Why negative? Because still tan is negative in the second quad. So you can say negative of the tan of the reference angle is 30. So you just have to be careful with the sign. Looking at that, the 30 is here, and tan is equal to, if you recall, tan of theta is equal to opposite over adjacent. So the opposite to 30 is 1. So we are going to have the negative of 1 over the adjacent. In this case is a root of 3. Adjacent to 30 is the root of 3. So we have over the root of 3 like that. Finding the conjugate, it will be negative 1 by the root of 3 on top and the root of 3 at the bottom. This gives us negative by root 3, it will be negative root 3 over root 3 by root 3. What is inside can multiply, so we have the root of 9. Negative root 3 over the root of 9 is a 3 like that. So this is the angle. This is the size of 510 degrees. Then to find the sec of theta, remember sec is equal to 1 over the cos of theta. So sec is associated with cos. So this gives us 1 over, what was our value for cos of theta? Now it was a fraction, so let's say divide by, remember the cos of theta is negative root 3 over 2, so we are going to put it there. Divide by negative root 3 over 2. Then this will turn into multiplication, in which these 2 will go up, so we have 2 over the negative root of 3. So this gives us 2 by 1, it's 2 over the root of 3. The negative will go here. So this is our value. This is our value. So this is our sec of theta as our value there. So we can find the conjugate by multiplying the root of 3. Root of 3, they like in conjugated form. So we have negative 2 root of 3 over whatever. If you are just multiplying like this, just keep what is inside. If the root is the same and the numbers inside are the same, just keep what is inside. So this is our answer. So this is our sec of 510 degrees. If you are looking at the cot of theta, remember cot of theta is equal to sine of theta over, not sine, but since it starts with c, you can put the cos of theta over the sine of theta. So in this case, what is our sine of theta? So this is the same as, first this is the same as cos of theta divided by our sine of our theta. What is our cos of theta? Cos of theta is the cos of 510, in fact 510 degrees divided by our sine of 510 degrees. So we found the sine of the cos of 510 to be equivalent to negative root 3 over 2 divided by our sine of 510 was equivalent to 1 over 2. So doing the cross multiplication, we are going to get something like this. Negative root of 3 over 2, this will turn into multiplication and the 2 will go up. So this and this cancels, and we are going to have the value which will be equal to the negative, which one is it? Okay, cot. So the negative of the root of 3. So this is our value of the cot of theta. Likewise, if you want, you can just say cotangent is equal to 1 over the tangent of theta. So even this one works. So you can say 1 over, what is the tan of 510? The tan of 510 degrees will be equal to 1 over the tan of 510 degrees. Tan of 510 degrees is negative root 3 over 3, like that. So we can just multiply or divide by our tan of 510 degrees. So this gives us a value that will be equivalent to 1 divided by our negative root of 3 over the 3. So this gives us 1 times the 3 over the root of negative 3. So we have 3 over negative root of 3. Just to make it similar, this gives us, just to make it similar, we have to conjugate. So it will be negative root 3, negative root of 3. This gives us 3. The negative is thrown here, so we have negative 3 root of 3. Then over the negative, and the negative will be equal to positive. So we have what is inside is just a 3 like that. So this 3 and this 3 cancel each other. Then we are going to remain with the root of 3. So that is the value of the cotangent of 510. So the cotangent of 510 degrees is equal to that. Thank you very much. I hope this video was helpful. Like, subscribe so that you don't miss out this very important content. Okay, I forgot that I have one question. Let's say we are told find the sine of theta, for which theta is equal to 15 pi over 4. So whichever way you choose to answer this question, it is still very much okay. So let's say we look at this one. So instead of converting it, we know that 15 over 2 is, if you remember coterminal angles, they have the same value. So you can get the other coterminal angle by subtracting or adding 360. So we are going to have our pi should be equal to 15 pi over 4 minus the 2 pi, like that. So this gives us, you can why subtract, because we know 15 over 4 is greater than 2 pi. So we are subtracting it to reduce it. If you haven't watched the video for coterminal angles, watch that video. So we are going to have theta should be equal to 4 is common. Then we are going to have 4 divided by 4 is 1 times 15. It will be 15 pi minus 4 divided by 1 is 4 times 2. It will be 8 pi. This gives us a 7 pi over the 4. So we need to convert this. We need to convert this by saying pi is equal to, we have 180 degrees. Then we have our 7 pi over 4 should be equal to x. Crossing multiply, this will be pi x should be equal to 18 degrees by 7 pi over 4. So this gives us already, this gives us this and this, it will be 45, like that. Then dividing by pi, this gives us a value of x is equal to 45 by 7. So multiplying 7 by 45 gives us 7 by 5, that's 35. 7 by 4, that's 28 plus 3, 29, 30, 31. We have 315 degrees. So with this angle 315 degrees, we can find now the coterminal angle. If you want, you could have just converted this. If you convert this according to our conversion video, this will give you somewhere 675 degrees, which you will have to use the principle of coterminal angles. So with this angle 315, that means to say the value of sine of 15 pi over 4 is the same as the sine of 7 pi over 4, or the angle 7 pi over 4 is the same as, it is 7 pi over 4 is equal to 315 degrees. So this is the same as, we have this, we are going to have 270 here. From 270 moving a bit, 270 moving a bit like that, then what we are going to have is a 315. So 270, 315, which will be here. So now 315 degrees minus 360 degrees gives us our 10 minus 5 is 5, 5 minus 1, that's a 4. So we are going to have our 45 degrees like that. So this is what we have. So this is what we have, 45 degrees here, and sine is negative in this quadrant. Therefore, without wasting time, we are going to say the sine of 7 pi, if you want you can use 45. Okay, the sine of 7 pi over 4 should be equal to, if you use the acute angle, account for its position. In the fourth quad, sine is negative, so we are going to say sine of 45 degrees, which will be 45 degrees is the same as the root of our, if you remember what our sine of 45 is equal to, if this is 45, opposite is 1, 1, then we have the root of 2, which gives us the sine is equal to opposite. In this case, it will be opposite of 1 over the root of 2. Finding the conjugate, remember, this will just be negative root of 2 over 2 like that. So this is the sine of our 7 pi over 4, so which is equal to sine of 15 pi over 4 is equal to the sine of 7 pi over 4, which is equal to negative root of 2 over 2. Our last question is, let's say the cos of theta for theta is equal to negative 480 degrees. So remembering our coterminal angle principle, we said that you add 360 or subtract 360. So the coterminal angle for 480 will be, negative 480 degrees. Since this is negative, we need to add. If it was positive, we could have subtracted, because 480 is greater than 360. So this gives us 0 to negative 120. So this minus this is negative 120. So that means to say we are going to be moving backwards. So from this point, this is 90, this is 120, like that. So this is negative 120 degrees, moving in the opposite direction. Then this will be, if this is negative 120 degrees, already that means to say this one has to be negative 60 degrees. So this one will be used as our reference angle. This will be used as our reference angle, since we are dealing with cos, and cos is negative in the third quad. So don't forget that. So this gives us our cos of negative 480 degrees is equal to, already it is in the second quad. So that means to say if this angle rotates like this, it passes like that, it makes 360, it continues, it will still end at this point. Then we use the reference angle, which is the angle between the x-axis and the terminal angle, like that. So this is equal to the cosine of negative, for that matter, negative cosine of our angle 60 degrees. In this case, it will be 60 degrees, which will be the root of 3, 1, 2, like that. So the cos of 60 is equal to adjacent, which is our 1. So considering the negative, so it will be negative our 1 over the hypotenuse, which is our 2, like that. So that is how you deal with reference angles. Thank you very much, and that's all for this video. See you in the next tutorial.